Yes, so I'm going to plonk myself on this table because I most definitely need my notes to get through this. So I will just see what I will cover. I will define Revert and its benefits, why circularity matters, overcoming the stigma of scrap and how we can redefine it, industry best practices, designing for recycling and circular economy right from the start, policy and legislative challenges, and the future of Revert. I think we're all quite aware of scrap. We're aware of the cost savings that are maybe associated with using Revert. But I think that today the understanding of scrap and Revert needs to evolve and not just see it as a cost-saving tool, but actually a tool for advancing net zero goals and building a more resilient, sustainable supply chain. While the economic advantage is well understood, Revert plays an increasingly critical role in supply chain resilience, strategic autonomy, and environmental responsibility. This is particularly relevant now amid growing uncertainty around international tariffs on raw material, which are creating volatility in both pricing and availability. In this context, access to high-quality Revert becomes not just a cost-saving tool, but a buffer against geopolitical and trade-related risk. Recent studies, such as one published in Frontiers in Chemical Engineering, show that increasing the circularity of nickel and cobalt through Revert practices significantly reduces the environmental burden compared to primary extraction. They noted that both mining and beneficiation stages produce high levels of volatile organic compound emissions and that recycling processes can play a key role in cutting overall emissions. So the key benefits of Revert include decarbonization. Revert bypasses the most carbon and energy intensive stages of primary metal production, mining and refining. Circular economy integration. Revert keeps high value metals in use, reducing demand for finite resources and supporting industrial circularity. Cost and efficiency. Utilizing Revert lowers material costs by reducing reliance on expensive virgin metals and avoiding the significant expenses associated with primary extraction and refining. And resilience and risk mitigation. In a landscape of volatile pricing and strategic materials risk, Revert buffers the supply chain against shocks, aligning with EU and UK critical raw material strategies. Revert should not be seen solely as a financial advantage, but as a strategic and ethical choice, one that balances economic, operational, and environmental priorities for a more sustainable future. Taking nickel as an example, there's a case study I want to touch on that is because as an element in superalloys and the green transitions, especially for EV batteries, hydrogen technologies and aerospace components, nickel is really important. This study by Olive Stotter and Sverdrup from 2020 used the World 7 system model to forecast the global nickel cycle, including supply, recycling and stocks in use, offering critical insights for both industry and policymakers. They estimate that total recoverable global nickel resources are at around 650 to 720 million tons. But since 1850, the quality of nickel ore has significantly dropped. As we mine lower grade ores, energy use and emissions go up while yields go down, and this trend is already making extraction more environmentally and economically costly. Nickel production is projected to reach its peak around 2050, with most economically viable primary resources potentially depleted by 2130, posing a serious constraint for both conventional industries and emerging green technologies. The crucial point is, if we improve recycling systems now, we can delay peak extraction by up to a century. That means more time to innovate, transition, and stabilize pricing. So what does this mean for net zero? It tells us that recycling isn't a nice to have, it's a must have. Especially clean, traceable Revert is a key part of the system. Circular metals keep critical materials in use, lower extraction emissions, and support long-term resource security. One thing I'm really passionate about is overcoming the stigma that's still associated with scrap. Historically, scrap was viewed as inferior to virgin material, largely due to contamination risks and inconsistent properties. Early recycling technology didn't help, producing variable outputs that couldn't always meet demanding specs. As Rain et al. In 2024 highlight, though, modern sorting, cleaning, and analysis technologies have radically transformed what's possible. We can now produce chemically verified, spec-compliant recycled alloys that meet even the toughest demands, especially in high-performance applications like aerospace or IGT. That's why we increasingly use terms like revert or secondary raw materials. They signal a shift in mindset. We're no longer dealing with waste, but with controlled, traceable inputs that underpin a low-carbon, resilient supply chain. Yes, some hesitation remains. A 2023 study by Smith & Brown showed many manufacturers still default to virgin metal, simply out of habit or fear of impurities. But the reality is, we now have the technology and data to close that trust gap. Quality isn't the barrier it used to be. If we want to meet net zero targets, we must challenge outdated assumptions and see revert not as second best, but as a strategic choice for environmental and operational resilience. When we talk about sustainability and circularity, what we call things matters. Terminology shapes perception, and perception shapes adoption. In high-performance manufacturing, we've long known that well-handled scrap can match virgin material in performance, but calling it scrap doesn't help build trust, not with customers, regulators, or the public. That's why it's important for foundries to lead the way in adopting terminology like revert or secondary raw materials when engaging with their customers. These terms more accurately reflect the controlled, traceable, and specification-driven nature of the materials we are using. By aligning language with quality and sustainability standards, foundries can help shift industry perception and strengthen confidence in circular supply chains. Other industries have already embraced this strategy. In plastics, the term post-consumer resin, PCR, has helped increase uptake by distancing quality material from waste stigma. For metals, using revert helps build confidence, especially in external sourcing, overcome legacy stigma, and promote consistent messaging around quality and circularity. Examples of companies successfully positioning revert as a critical resource include GE and Rolls-Royce. GE Aviation actively integrates revert material into its manufacturing processes, particularly in the production of superalloys for jet engines. Through initiatives such as the Military Engine Reclamation Program, GE recycles engine scrap and non-conforming parts, significantly reducing reliance on virgin feedstock while upholding strict aerospace standards. To date, the program has enabled the recycling and reuse of over 1 million kilograms of hardware, delivering both measurable environmental benefits and substantial cost savings. Rolls-Royce's Revert program is another prime example of a closed-loop recycling system in the aerospace sector. Internal scrap, including turnings, offcuts, and worn components, is reclaimed and reprocessed into new high-specification parts. The program supports both sustainability goals and operational resilience by reducing the need for virgin raw materials, minimizing energy use and CO2 emissions, and operating globally across more than 100 sites. Notably, up to 98% of a used aero engine by weight can be recycled, with approximately 50% of the recovered material suitable for remanufacturing into new components. While often viewed as a technical or compliance issue, traceability and robust process control are essential pillars of sustainable and ethical sourcing. At ICD Europe and across any ISO-accredited facility handling revert, rigorous controls ensure that materials are responsibly sourced, chemically verified, and processed with minimal waste. Every batch we receive is assigned a unique goods receipt number, which follows it through every step, from material identification and testing to segregation, preparation, and final inspection. The system not only ensures full traceability, but also reduces unnecessary rework and waste, supports confidence in recycled inputs, and enables data-led sustainability reporting, which is increasingly required across industries. Robust revert handling protocols ensure traceability, consistency, and quality, enabling recycled materials to meet the demands of high-spec applications while supporting circular and low-carbon manufacturing. Design for recycling is no longer a niche sustainability feature. It's becoming central for net zero strategy in high-performance manufacturing. DFR means intentionally designing components for material recovery, easy disassembly, and minimal waste. When done well, it enables the reuse of critical elements, reducing dependence on primary extraction and lowering life cycle emissions. A 2023 study by Dybeck focused on jet engines emphasized that systematic end-of-life planning can significantly reduce the need for new materials, energy-intensive manufacturing, and mining. It's an environmental and economic win. We've already seen good DFR examples in investment casting. Turbine blades and vanes made from single alloy nickel or cobalt-based materials with minimal coatings. medical implants made from high-purity homogeneous alloys, easily segregated after use, turbocharger components that are chemically consistent and well-suited for efficient remelting. Key DFR principles include single material construction, minimizing coatings and surface treatments, avoiding adhesives or permanent fixing. When design ignores recyclability, using composite materials, heavy coatings or bonded layers, we lose valuable revert potential. Circularity starts at the drawing board. By planning for the end from the beginning, we make high-value material recovery practical, predictable, and profitable. There are, of course, advanced manufacturing sites, including those in investment casting, that have developed in-house revert processing capabilities. This allows them to reclaim and reuse internal and customer scrap with full quality control, creating a steady flow of verified material back into production. But not every facility has the tools or capacity to manage this independently. That's where partnerships with recovery and recycling specialists become essential. These partnerships help manufacturers to process revert to strict metallurgical standards, minimize material loss and contamination, reduce reliance on virgin feedstock, and accelerate the progress towards net zero targets. By working together, recovery specialists and manufacturers close the loop, ensuring that high-value material isn't wasted simply because of lack of in-house processing infrastructure. This is especially important in precision sectors like aerospace, energy, and medical, where every input must meet exacting quality criteria. In short, a shared approach to material responsibilities enables a more circular supply chain, greater resource efficiency, and a practical path to decarbonizing high-performance manufacturing. We're currently seeing a wave of new policies across the EU and UK aimed at strengthening local supply chains and driving the green transition. One specific proposal that's raised concern in the EU is the EU's suggestion to limit scrap metal exports to keep critical raw materials within member states. This initiative aims to bolster domestic industries and support the EU's green transition. However, industry associations like the European Recycling Industries Confederation have raised concerns, suggesting that such restrictions could adversely affect the environment, economy, and the EU's global competitiveness. EURIC emphasizes that export restrictions may lead to an oversupply of scrap within the EU, resulting in price depressions and threatening the viability of recycling businesses. They argue that open trade is essential for the recycling industry's survival, and that protectionist measures could in fact hinder Europe's circular economy objectives. We are navigating complex legislative landscapes to balance resource security, environmental sustainability, and economic viability in the management of revert. As an industry, we must actively engage with policymakers to ensure that the future of revert remains secure and supports the development of sustainable supply chains. By proactively contributing to regulatory discussions, we can help shape policies that facilitate circular economy principles, maintain competitiveness, and promote responsible material use. The EU's Carbon Border Adjustment Mechanism, or CBAM, is a regulatory game changer. It places carbon cost on imported goods that don't meet the EU's environmental standards, beginning with sectors like steel, aluminium, and cement, but with a broader scope on the horizon. While nickel and cobalt alloys are not currently included in CBAM scope, many customers are already requesting carbon data for these materials in anticipation of future inclusion. It's increasingly seen as a matter of when, not if. For anyone working with high emissions or energy-intensive metals, this means embedded carbon in materials must be tracked, verified, and declared. Revert, especially when sourced through low-carbon or recycled channels, becomes a strategic asset. Using certified low-impact recycled inputs can directly reduce CBAM exposure now and in the likely future. In this context, Revert isn't just a sustainability win, it's a forward-looking compliance and risk mitigation tool. At the same time, we're seeing a global push for ESG transparency, and that affects every tier of the metal supply chain. Even companies that aren't directly subject to ESG regulations are now being asked by their customers and investors to show where the materials come from, provide clear traceability and responsible sourcing declarations, demonstrate a lower environmental footprint and alignment with circular economy goals. Revert ticks all of those boxes, but only when it's properly processed, tested, and documented. That's why it's so important that we move away from seeing revert as just scrap and start positioning it as a certified, traceable, ethical input. Both CBAM and ESG frameworks are not going away. In fact, they'll only become more demanding. But for companies who embrace revert and invest in transparent circular practices, these frameworks become opportunities to stand out, to de-risk their supply chain, and to build credibility with regulators, customers, and stakeholders. Looking ahead, revert isn't optional, it's essential. It's not longer just about the cost and operational efficiency. Revert is a strategic enabler of carbon reduction, resource security, and a truly circular economy for high-performance manufacturing. The metals we rely on, like nickel, cobalt, hafnium, tungsten, are not infinite. Their extraction is energy-intensive, geopolitically sensitive, and environmentally costly. Revert provides a viable path to reduce our environmental footprint, extend the life of critical resources, and increase supply chain resilience in a volatile world. But achieving this vision requires true collaboration across the value chain. Designers must plan for end-of-life recovery from the outset. Manufacturers must view Revert as a primary input, not as a secondary fallback. Recyclers and recovery specialists must innovate to keep quality, traceability, and availability high. As Zhu Sarkis-Lai noted in 2022, the future of circular manufacturing depends not only on technical capability, but on shared responsibility and systemic thinking. Revert is no longer the byproduct of yesterday's process. It's the foundation of tomorrow's performance. Sorry. It's the foundation of tomorrow's performance. And that's it.